Okay, so neighbors, now we are going to see more examples of the anti-normalization. Let us start with this question. The marks of 500 candidates in a mock are normally distributed with mean 45 marks and standard deviation 20 marks. If the pass mark was 41, estimate the number of candidates that passed. So if we get the number of candidates, we need to know what's their probability. So we need to know the probability of candidates that got above 41. We need to know those numbers. So it said, let x be the number of, let x be the marks, not number, the marks of students here. If passed, we need now to know this pass mark first. So now, this will be, now I need to know the probability of number of students which are x that got above 41. The mark, let x be the marks of the students. So if x is above 41, now you need to know that probability. If you know that probability, now we shall multiply the probability with the number of students and we will get those students. So now to get this, we need to first normalize this, standardize it. So this will be probability. Now is z greater than. Now this one will be 41 minus. Do we have the mean? So they gave us mean, our mean from that question with mean 45. Then standard deviation they gave us is 20. So you have everything. I don't know how we standardize. To standardize, we use the formula of x minus b, the whole over sigma. This is what I'm using. So z is equal to the mark which is 41 minus now mu. My mu is 45. The whole divided by 20. And so this will be the probability of z above, and that will be 4 divided by 20, which is negative 0.2. Now this one, where is it going to be? So you draw a simple sketch so that you can interpret it properly. You see it's z, it's here, negative 0.2. So this is now a standard normal with mean 0. So above this, so greater than this. That's what we are looking for. So this will be equal to, we shall get 0.5 plus the probability of this but modulus of it. Why? Because you can only need this z value if it's positive, and this will be 0.5 now plus probability of 0 less z less 0.2, which will be 0.5 plus, read this from the table. Read that from the table. I am finished to show you how to read it. Mine here is 0.0793. We give it 4 decimal places, and when we add, this will be 0.5793. So this is the probability of students that got above 41. Now to the number of students. Now our number of students. Number of students will be now, we get 500, they are total. Now times these ones who got above this 793. Times their probability. So we shall get now there. So here I'm getting 289.65. So here I estimate that there were approximately, you give the next integer. The next integer after 81 point this is 290. So the students who passed were 290. Then now to part B. Our part B, this was our part A. In part B, you number please. If 5% obtain a distinction by squaring x, marks or more, estimate the value of x. Now, for the mark x, we say x is the mark, to be greater or equaling to x or more. Now, the thing that's that this were 5%. So this one is the one, this, whoever got a mark greater or equal to this is the one who their percentage is 0.5%, which we can easily convert to 0.05. So we first standardize this, So this will be probability of Z greater. This will be X minus 0. Our mean was 45 over the 20 equaling to 0.05. Now what we do there, this one now we are anti-normalizing this, anti-normalizing this. So now we get this value here. So how do we sketch that? To sketch this, you draw a simple scale that you can interpret this properly. So it's that this one is 0.5. It's greater, so meaning it's somewhere here, greater than that, which will be 0. Now the parameter of that, we need this ZP, but the parameter there, they are giving us that the whole of this is 0.5, but you say that one, because it's the one which is greater, but the parameter there is 0.5, and you say this is the same as 0 minus P, because this is P, and we say that the whole of this from here up to here is 0.54. So if this is P, then this one is going to be 0.5 minus P. So this one now, 0.5 P is equal to this. So 0.5 minus P is now they are telling us that probability here is this 0.05. So our P is that our P is going to be 0.45. Now read off this from the table. After getting P, now read from your ZP. This one from the table, when I read from my table, I take now there. People know how to read these values. Me, I'm getting 1.645. After reading that from my table, then now this is the ZP here. This is now our ZP. Why? Because we are looking for this idea. Z greater than ZP equaling 0.05. So that our ZP is that. So now our X minus 45 over 20 will be equaling ZP equaling 1.645. So now there, if I cross multiply, my X will be 45. I take this beside 10 plus 20 times 1.645, and so my X. The mark there is going to be 20 times 1.6. So the mark is 77.9. So now, so these students whoever scores 77.9 is going to get a distinction. And so that would be the answer. Estimate X. So if you can give it 2, now you can estimate it now 78. So the marks. You give it the next integer. So that's it, members. The next integer after 77 is 78. So whoever scores 78 or above is going to get a distinction from that more. So that's it, members. That's how we use the anti-normalization. Now we are going to see what happens if now some questions they want you to get sigma and then mu. See you there.